Eric Bennett, University of Copenhagen. Solving an unmet genome editing need. Fast, accurate and robust Indel detection by Amplicon analysis, IDAA.
Precise genome editing technologies are dramatically changing the way gene-based therapies are being developed nowadays. Now, we discovered that there's an unmet need in the field of precise genome editing, and I'll try to convince you or show you the methodology that we developed called IDAA. Briefly, genome editing tools, first generation, in 2011 were appraised as the method of the year in Nature Methods. In 2013, very recently, the CRISPR craze initiated another wave of genome editing. And in Science magazine last year, 2015, announced CRISPR as the technology of the year. These tools, technologies, next slide please, yes, have found the basis of major companies exceeding more than 400 million USD in company investments. And on top of that, milestone agreements with the editing companies and big pharma exceeds the hundreds of millions of dollars. To the right, you can see the sort of first generation biotech or genome editing companies that have also raised billions of dollars. And the common denominator for this technology is that they want to enter into the therapeutic field. Next clicks. Next click again. Now, what they envision, one of these envisions is that the ex vivo treatment of patient cells extracted from the patient can be genome targeted with these tools, CRISPR, TALENs, zinc fingers, whatever. And then these edited cells, modified cells, will be transfused back to the patient, hoping that they had, that the editing has been achieved. Now the big question mark here is, and the problem is, that, next click please, that the therapeutic window most often is only 2 days before, from extracting the cells from the patient, treating the cells, before they have to be returned. So you have an opportunity of 2 windows, which is what we call the therapeutic window. Next slide, please. Next slide, please. The only way that you can monitor whether the genome targeting technology has done its job is by conventional next-generation sequencing, which, as you can see, has a very high sensitivity, very good resolution. But as you can see, it takes more than 5 days to complete. So you exceed the therapeutic window. Next slide, thank you. Sanger sequencing is another option, but the sensitivity and resolution is an issue here. Next click, please. And here we come with the IDAA technology that can be completed within 1 day and has the sensitivity resolution required to do the analysis. Last slide. We have demonstrated that the principle is superior, has a superior discrimination power. Next slide, please. We have also published that it has high throughput enumerable capability. Next slide, please. And that the discrimination power is identical to next generation sequencing. Most importantly, we have a patent covering the technology, and I would like to hear that if anybody is interested in exploring the therapeutic potential of the technology, I would like to speak to you after this session.